So this is an example of a simplest ripple filter. So in ripple filter, you have an AC source, you connect a capacitor across that. So the output voltage is little bit muffled because of this capacitor. So that's why it's called a ripple filter. So it controls the ripples, this capacitor. So in the problem, it's given that the input voltage is V0 1 plus cos omega t. That's fed here. We need to find what will be the output voltage. And then we need to find what will be the RC at which output amplitude of alternating voltage. Okay, we'll see this part later. Let's just find V dash t first, because second question is related to V dash t. So once we find V dash t, this second statement will make sense. So first, we need to find what is the voltage across the capacitor. So before solving this problem, because here we have a DC component of voltage as well. So if we had only this circuit with normal AC source, then calculation of this voltage across capacitor will be simple. But here this has a DC source. So let's assume the source is AC and try to get the answer which we know, which is the voltage across capacitor. So we know, let's read this first and then we'll read that. So we know that in a RC circuit, the voltage across capacitor is given by V0 into XC by Z into cos omega t minus phi. So in the phase diagram, we know that voltage across capacitor lags behind voltage by phi amount. And phi is tan inverse R upon XC. So tan inverse R upon 1 by omega C. So that's why this equation will become cos of omega t minus phi. Omega t is the voltage and Vc is lagging by phi. So this term becomes omega t minus phi. And the amplitude is of course V0 into Xc upon Z. So V0 into the capacitive reactance upon total impedance. So we know this is the solution of a RC circuit. Now where that solution came from? So that solution came from this equation. So if you take the loop for RC circuit, what you will get is V0 cos omega t minus IR minus Q by C is equal to 0. Or I we can write as dQ by dt. So this term becomes dQ by dt plus Q by RC is equal to V0 by R cos omega t. Now when we do solve this equation, so we have to use integrating factor and all that. So that's a bit lengthier process. But if we do solve this equation, this is the root which we get of this equation. So this is the solution, not root. I mean the solution of this equation is this. So that's how we actually get this. But in phasor diagram, we don't want to do all those calculations. So we just simply shorthand it and see that we get our answers through these phasor diagrams that are the direct solutions to this problem. So to this equation, mathematically, this is the solution. Now let's come to our original problem. So here our AC source is V0 1 plus cos omega t. So again, if you write the KVL here, it will be V0 1 plus cos omega t minus IR minus Q by C is equal to 0. So we rearrange it in this form. So obviously this is different than this. But what we do here is we rearrange this a little bit. So we take this V0 by R on the left side. So that term will become this. So V0 by R cos omega t is still on the right side. And instead of dQ by dt, let's write it as d by dt of Q minus CV0. CV0 is a constant. So anyway, d by dt of that will be 0. So this equation did not change. This equation is same as this equation. But now if you compare 1 with 2, you can see everything is same except that Q is replaced by Q minus CV0. That means the solution of this equation also we can just replace Q by Q minus CV0 and that solution will be valid. So since equation 1 is similar to equation 1 here, so solution 2 should be similar to solution 2 here. So we just replace Q by Q minus CV0 and rest the equation is same. So this is the valid solution. Now we need V dash. So V dash is Q by C. So from here we see Q by C is V0 plus V0 XC by Z. So XC is 1 by omega c, z is this. So we put those values and this is our answer. So you can see the voltage, output voltage is muffled a little bit. So initially for the input voltage, the amplitude was V0, but now the amplitude is less than V0. So the voltage is rippled. Now we have got V dash in this form. So now let's read the second part. So in second part, we need to find the magnitude of the product RC at which the output amplitude of alternating voltage component. So this is the alternating voltage component of which the amplitude is this. So that's what it is saying. This amplitude is eta times less than the direct voltage component. Direct voltage component is this. So it's saying that V0 by eta should be equal to this, or eta should be this denominator. That's why it's asking, if that is the case, what is the value of RC? So let's quickly see that. So V0 amplitude of alternating voltage component, so that is this, is equal to 1 by n times amplitude of DC component. So that's V0. So amplitude is nothing but, since it's DC, it's constant, it's V0. So n is equal to this thing. So n square will be, so you just solve that and you will get RC to be root n square minus 1 by omega. All right.